Welcome, everyone. This is Segmentation with Cisco Catalyst, SD-WAN, and ISE. I hope everyone enjoyed the keynote. I know we still got people trickling in, but we're going to go ahead and get started just to take advantage of everyone's time. There's a lot of content here. My name's Steve Penland. I'm a solutions engineer on the SD-WAN and routing team, so I get the opportunity to work with a lot of customers on their WAN, understand their challenges, and help them come up with solutions to that. Just a couple quick notes. If you have questions, feel free to raise your hand. I'll try to address them live as time permits. But you can also go into the WebEx space, put questions in there. I've got a couple of people looking at it while I'm presenting, and then I'll take a look afterwards, make sure any questions that weren't answered do get answered, and then I'll monitor. I'll look at it for a couple of days after, in case you think of new ones. Oops. So the agenda today, we're going to do a quick introduction. Really, what is segmentation? What do we mean by that? We're going to talk about the different types of segmentation, so macro segmentation and micro segmentation. Look at those use cases. I'm going to do a demo so you can actually see how this all works live. And then I'm going to dig into a little bit of what we can do with identity-based firewall ruling based on that integration we've got with ISE and SD-WAN. And then we'll wrap it up. So to get started, why is network segmentation important? You guys probably have an idea of that or you wouldn't be here. But really the genesis of this session came about just because we're having so many conversations with customers that are asking us, how do we segment our network? We've tried it in the past, we've hit a lot of pain. Help us figure out how to do this because we're getting told by our leadership and our security teams that we have to do it. So to come up with a way to kind of describe why it's important, I did a little bit of searching. I found an article by the NSA, and they did a really good job summarizing why our company is trying to do this. And just to highlight the first sentence there, it talks about how after gaining access to an organization's network, one of the most common techniques cyber attackers use is lateral movement through the network, gaining access to more sensitive data and critical systems. So when we talk about why is segmentation important, that's pretty much it. So it's actually a really interesting article. I got the link there. Feel free to take a look after the session. Some good information. What are the fundamentals of segmentation? There's really just a few things, if we want to boil it down and summarize it, that segmentation is. It's identifying the users and devices that are trying to access the network, determine if they should be allowed access. So is a user trusted? Is he on a trusted device? Is the device compliant? Assign that device or user to a segment. That could be a VLAN, a VRF, an SGT. I'll talk about what all these are here in a minute. But just for now, those are segments. And then let's create and enforce policies determining what segments should be able to talk to which other segments and over which protocols. So those are kind of the fundamentals of what are we trying to achieve with segmentation. Now, I summarized it and that seems pretty simple, but obviously if it were easy, we would have all done it by now. Yesterday's keynote, G2 mentioned segmentation's been hard, and we would tend to agree with them. Traditionally, we've tried to segment using VLANs and ACLs. It became a management nightmare trying to manage the IP addresses. Everything was device-based. We moved to VRFs, where it gave us another level of segmentation. But we had to deal with how do we maintain that segmentation end-to-end across the network. We could use service providers that have private networks, and they would happily sell us multiple VRFs. But we'd have to pay for that, right? So if we had 4 segments and we wanted to move to 5, your bill just went up incrementally. And if we wanted to use different transports to maintain that segmentation across like internet, we had to do some sort of complex overlay and routing to make that happen. SGTs, they have problems of their own. And I'm going to go through what SGTs are, and we'll highlight the problems of them as well, but it really comes down to scale, and again, maintaining that segmentation across the network. So what we're going to talk about today is how ISE and SD-WAN are going to help kind of enable that segmentation. So the goal would be, as you guys leave this session, to understand that there are a couple of tools that you may already have that are going to help make segmentation achievable. Before I go further, how many of you guys are ISE customers today? Just show of hands. All right, good deal. And SD-WAN, Catalyst SD-WAN? All right, good deal. So I'm not going to go into what is ISE and what is SD-WAN. This is kind of more of an advanced session where I think we kind of understand those fundamental pieces. I'm going to focus really on the segmentation here. So the first thing we need to do to enable the segmentation is we have to authenticate devices and users to the network. ISE is going to handle that authentication for us. So when a user connects to a network device, it's going to reach out to ISE to perform that authentication. And ISE is going to use a number of different ways to authenticate it. One way is using external identity stores. So this would be, if my users are logging in via Active Directory or Azure Active Directory or LDAP, another method would be to use certificates to authenticate the device or user. And another would be single sign-on. So through integrations that ISE has with Ping, Okta, Azure Active Directory, and so on, we're able to identify what are these devices and users. And we're using different methods to do that. There's this concept of passive identity. So this is going to be for devices that don't have the ability to install a client or an agent or a certificate. So think machines, right? I've got a machine or a HVAC system or a monitoring system that is unmanaged, but it needs to be authenticated to the network. Those are going to be using passive identity, like MAC addresses, to do that authentication. And then we have active identification. That would be 802.1x, web authentication, methods along those lines where there's interaction between the end device and the actual authentication. Once we've authenticated, we then need to put the device or user into the appropriate segment. So we use a couple of different methods to do so. We can do dynamic VLAN assignment, where if a device authenticates and we see it's an employee, let's put it in VLAN 3. If it's a printer, it goes into VLAN 5. We can then do things like downloadable ACLs or named ACLs and create rules that basically say employees can access these servers or services, contractors, different services. And eventually we can get to this secure group tag, which we'll focus on a lot today, where instead of assigning a VLAN or an ACL, we basically assign an SGT or secure group tag, and then we build policy as to what this tag should be able to access. And so those are the different enforcement options that we've got once we've authenticated the device. Now, how SD-WAN is helping here is it's going to act as the transport as well as the enforcement. So if we're looking at macro segmentation, we can take multiple VPNs and stick it into a single SD-WAN overlay and then keep those segmented end to end. If we're looking at SGTs, we can have a single VPN and have different tags within that VPN and then maintain that segmentation, again, across the WAN end to end. So let's take a deeper dive into those two different use cases and understand how they work. So first of all, when we talk about macro segmentation, we're really looking at what is a VRF or a VPN, and they're the exact same thing. Traditionally, Cisco's used the term VRF, or virtual routing forwarding. SD-WAN has used VPN. If I log into the router in iOS XE using CLI, I'm going to be looking at VRFs. If I log into the GUI, I'm looking at VPNs. Like, that's just the way it is. They mean the same thing. Essentially, it's a separate routing domain. So if I have prefixes in VPN 1, prefixes in VPN 2, they don't know about each other. There's no communication by default. SD-WAN has a couple built-in VPNs. VPN 0, which is our transport VPN. It's our global VRF. That's going to be where we build all of our tunnels from. And then VPN 512, which is our management VRF. You can then assign a number of service VPNs. These are going to be what actually connect to your users and devices. So they're facing the local area network. You can have one or more. The number of VPNs that are supported is hardware dependent. The smaller routers will do like 64. The bigger ones will do 300. Usually, customers are doing under 10, I would say. And the use cases for these would be to support segmentation where we have different segments that have really no need to talk to each other. So guest users, IoT devices, and then trusted devices. Maybe these shouldn't ever talk. So we can put them into different VPNs and keep them separate from that perspective. Compliance is another good use case. A lot of different industries require segmentation. VPNs, VRFs, they help us solve that. And then mergers and acquisitions. So company A buys company B. Let's say they need to connect the network together. The engineers start talking. They realize they're using the same IP address space because everybody's using the same IP address space, right? We take company A. They're on VPN 1. We ship a couple routers to company B. We put them on VPN 2. And then we can keep them separate, bring them back to some centralized point, and do a NAT in the, maybe at a firewall at a regional hub. So that's a good use case as well. How do we place them in the correct VPN? In the correct VPN. It's really ISE that provides us that mechanism. So as we're authenticating the device again, we're basically using our router or switch or wireless access point. It's connecting to ISE via radius. It's authenticating the device, and then ISE is providing the VLAN assignment, I should say, that the device should go into. And the way this works is we essentially have an authentication policy where we have some conditions. In this very simple example, we're authenticating users using MAB and 802.1x. And then we have our identity stores. So for example, if we're doing MAC authentication bypass, maybe we're looking at our internal endpoints which are in ISE. If we're using .1x, we can look at things like Active Directory, LDAP, and so on to authenticate those devices. And the way to read this, when you go into ISE and actually start using it, is we have these different authentication rules, right? So MAB being first in this example. What'll happen is if my initial authentication fails, meaning we find the MAC address and it should not be allowed into the network, we're going to reject that device. If that MAC address is not found, it's going to continue on to the next method in the list, right, which is .1x in this case. And again, we just continue to evaluate those as we go through the list. Once we have authenticated the device, we assign it to an authorization profile. And this is where customers start to say stuff gets complex and kind of scary. It's really an if-then condition. So if the device or user equals X, then assign it to Y. So for example, the top one there, it's a wireless device, which has an identity that matches a group called block list. Let's assign the profile block wireless access. The second one is if it matches an identity of Cisco IP phone, let's put it in the Cisco identity a Cisco IP phone profile. And then within that profile, we assign it to a VLAN. So in this case, pretend it's the phone, we assign it to a VLAN of 10. Now the way the VLAN gets into a VPN, which can be then maintained across the WAN, is a couple of different options. One is a layer 2 trunk from the LAN to the WAN, and I should explain, we got some new icons. So the rectangle on the bottom is a switch. The thing with the funky pointing circle, that's an SD-WAN router, right? So the idea is, and you'll see those throughout this presentation, so I just wanted to point that out. The idea being you trunk to the router then puts the VLAN into the correct VPN. And so in this example, devices attached to VLAN 10 cannot talk to devices on VLAN 20. The other option is you use a routing protocol that's VRF aware, and you can actually just do routing between your LAN and your WAN to extend that VLAN to VPN mapping. Now, let's say you have devices in different VPNs that need to talk. An example would be we've got a user in VPN 1 that needs to talk to VPN 2. They're at the same branch. The way we can do this is route those devices up to some sort of regional hub. Maybe we've got a firewall where we're enacting policy as to what is allowed to talk between these VPNs. And we can allow that firewall to do the bridging, right, between VPN 1 and VPN 2. Same thing if you have two different offices, right? So let's take the remote office with VPN 3. Maybe that's a new acquisition. We got our VPN 1 user, needs to talk to our VPN 3. Again, what we would do is route it back through some sort of regional aggregation point, and we would allow that to bridge between the two VPNs. In the case of maybe duplicate IP addressing, you could do the NAT on that firewall as well. That's kind of the traditional way we've handled connecting the VPNs together. The other use case is I've got two different VPNs in the same branch. Like maybe I've got users that need access to very specific IoT systems, and they're in different VPNs. What we can do is route leak locally between the two VPNs, and we've made this pretty easy to do in SD-WAN, where we can advertise VPN 1 routes into VPN 2 and vice versa. And then we've got a firewall stack sitting on the router, which can only permit specific traffic, right? So you can actually build rules that says for VPN 1 users talking to VPN 2, maybe only allow a specific protocol and only allow that traffic in one direction, for example. All right, so that was macro segmentation. Let's talk a bit about micro segmentation. So this is where a lot of customers are kind of coming to us today. The macro segmentation's been around a long, long time. TrustSec is a Cisco technology that we use to achieve microsegmentation, and it relies on the use of these security group tags, or SGTs. And to give you a high-level idea of how this works, I've got my employee on the left. He's going to connect to the network, and he's going to be assigned an SGT of 5. Oops. Let's say he then wants to send a packet from the employee with SGT of 5 to one of the servers on the right. And again, those are getting their SGTs the same way, right? They're attaching to the network, and they're being given an SGT value on the remote end. We're then going to propagate, as part of that packet, the source SGT value. The receiving switch on the egress is going to look at the policy that's been applied, the policy that's built in ISE, and it's going to determine whether it should forward or drop that packet. So if my employee was talking to my app server, it would be allowed, but if it was talking to my prod server based on this policy, it would be dropped. That is, at a very high level, how TrustSec works. It uses these tags and a matrix to determine what should be able to talk to which other segments. The way we classify this is the same as how we classify our macro segmentation. We use ISE to, again, authenticate the device. The big difference here is the fact that you can have all of these different segments within the same VLAN. So instead of deploying 10 or 12 VLANs at your remote branch, maybe you can get it down to 1 or 2, right, and just have one VLAN. But I have different devices and users in that VLAN with different tags. And so in this example, my employee is given my employee tag, my supplier is given the supplier tag, and unless, depending on what the policy says, they may not be able to talk to each other even though they're in the same VLAN. That's kind of the power of the micro-segmentation piece. The way this works from an ISE perspective is it's the same if-then screen I showed before, where we're authenticating the device, we're looking at some conditions. The difference here is instead of just assigning a profile, we can also assign a security group. So based on the conditions on the left, we're going to group things into maybe employee or quarantine system, and that's how that gets pushed down from ISE to the network access device. Once we have the tag assigned, right, by the network or on the network access device, we need a way to propagate it across the WAN. And there's two different ways we can do this. One is kind of the easy way, which is inline, where essentially we're just taking the tag. We have to move it around a little bit between the frame header and a packet header, but we can actually maintain that tag across the entire wide area network. SD-WAN enables this. This is the preferred method. The other method that a lot of customers have tried to use and stumbled upon before kind of SD-WAN helped solve this problem was using SGT Exchange Protocol, or SXP. And the idea with SXP is that you've got some sort of intermediary device or network, right, could be the WAN, that's not SGT inline capable. So at some point that tag gets stripped off between the source and the destination. And what we need to do is find a way to advertise those tag/IP bindings across the network in this case. So in this example, the user, which is 10.0.1.2, is being given a tag of 5, and the switch that is putting that tag into the source packets, which is underneath the user there, he's going to advertise that binding of 5 to 10.0.1.2. He's going to advertise that as an SXP speaker to a router across the network who is an SXP listener. The same thing happens to that 10.4.9.5, which has been given an SGT of 6. That gets advertised to that router as well. So the router now has the source and destination tag, and it's able to do enforcement as a result of that. That works well in a small network, right? That's fairly easy to do. The problem comes when you have to do larger networks. So the first thing to know is typically the SXP listeners and speakers, they have a limited number of peering relationships they can form. So if I've got 2,000 sites, there's no way I can build a full mesh of SXP between all of the devices. I have to use an SXP reflector, which I've put in here as this orange device up at the top. And essentially the way it works is the SXP reflector is going to learn all of the bindings, and it's going to advertise it to the different sites. And this works well for sites that can handle the scale. So in this example, let's say the total number of bindings throughout the entire network is 35,000, which seems big, but in a big enterprise network, 35,000 bindings, there's probably more than that as far as the number of IPs in use. We advertise it to site 1. It's got a Catalyst 9400. That can support 40,000. We're good to go. Site 2 is the same. The problem is site 3 is using Catalyst 9300s. Those can use 10,000 bindings. Right? So at that point, we've hit a limitation where my site 3 cannot do SGT enforcement because it can't download the entire IP to SGT binding map. And that creates the problem with SXP, is that you have a hard time scaling this to a large number. The way inline propagation solves this is pretty simple. Instead of needing to learn the entire binding map, we only need to learn the bindings that are happening on our device. So in this example, we'll have site 1. He's connected to the switch on the left. He authenticates, gets an SGT of 10. Site 2, the user authenticates, gets an SGT of 20. Let's say one is an employee in finance, one's an IT employee, right? So they have 2 different SGTs because they have 2 different corporate functions, but they need to be able to talk to each other. So let's say our SGT10 has a source IP at 10.50.1.1. He sends a packet to 10.60.1.1. The source sends the packet. It's received by the switch. The switch knows this mapping because it already authenticated the device, so it adds the SGT source of 10 to the packet. The switch then forwards it to the router. The router takes the SGT value out of the frame, puts it in the M data header in the packet, sends that across the WAN. The reverse happens now at the receiving side. We put the SGT for the source back into the CMD header of the frame. And now the receiving router, he doesn't have to know about the mapping for the 10.50.1.1 because it's already in the packet. He only needs to look at this packet and say, hey, I need to look up the destination SGT, and I know it because that address is connected directly to me, so I add the SGT for the destination of 20. So in this case, the number of bindings that each switch or device in the path needs to know is only the ones that are directly connected to them, so the scale is going to be fixed from that perspective. How we enable this in SD-WAN, couple of quick things you have to do. On your WAN interface, you enable CTS SGT propagation. It's just one checkbox within the WAN interface template. It's going to add the CTS manual command. A note is that it will bounce the interface. So be careful you do that in a maintenance window. From the LAN side, a couple extra steps. We enable the propagation. The thing that trips up some customers, and they ask this question, is what is that security group tag value in this specific case? And in my example, it's 2. What this is saying is any packet that comes into the router, which is not tagged already with a source SGT value, let's give it the value of 10, or I'm sorry, 2. If the packet does have an SGT value already assigned to it, then that trusted box right below it says, let's trust the SGT value that it's already marked with. Now, usually, your end devices, right, your laptops, your HVAC sensors, all this stuff, that's going to have a tag already. What usually comes in untagged would be like network control traffic. So I got a loop back on my switch. It's reaching out to an NTP server. That might not come in tagged. So the router's going to tag that on ingress as 2. This is the CLI that'll get added, more for your reference than anything. Again, this is going to bounce the interface. Anytime we do that CTS manual command, it's going to bounce the interface. So just something to note. So once we've got our policy, or we've got our tags assigned, we've figured out how to propagate it, the next step is to build that policy. This is done in ISE. This is just an example matrix. I'll actually do a demo of this here in a bit. But we essentially choose our SGT sources, our destinations, and then we build rules as to what should be able to talk to each other. And we can use these things called secure group access lists to permit specific protocols or deny specific protocols. I'll show a demo of that. So just taking this one step further, let's say we want to do enforcement on the SD-WAN router. And you could ask, why do we want to do that? A couple of different use cases. One would be we've got a site that does not have a switch capable of inline tagging and enforcement. Maybe we need to do it on the router then, because we can't do it on the egress switch. Another use case would be a site that doesn't have a switch. Maybe we're just using the router. Maybe it's one of those devices that have like 8 ports that we can just plug in a couple connections to. We can do the enforcement there. And then the last use case, which is what I'm going to show, and I've had quite a few conversations around this lately, is we've got all this great segmentation throughout our network, but we need to extend it into the cloud. So we want to bring our SD-WAN fabric, move it into Azure or AWS or GCP, or maybe one of our SDCI providers like Equinix or Megaport, and we need a way to then do SGT enforcement on top of that. So what we can do is, on the virtual router that we're deploying in those environments, we can do our enforcement there. And so that's a pretty interesting use case. The way we set this up for enforcement, and I'm not going to go through every field because I just don't have time, this is more for your reference than anything, is we need to configure a radius server. So the radius server provides the SG ACL maps to the router. So this is how, when we make a change to that policy in ISE, it gets pushed. It's through radius. Once we've created a radius server, we create a radius group. We assign that radius group to our CTS configuration, which CTS is Cisco TrustSec. And then we configure SXP. And I know I told you SXP has problems. There's holes with it, right? So why am I using it? It's to handle those very niche use cases. You won't want to do this throughout the entire network. The one thing I will say is, I showed you how a 9400 has 40,000 bindings, a 9300 has 10,000. A virtual router has hundreds of thousands, right? So if you need to scale the bindings, a router is a good place to do that. So that's one use case here. The big thing to note with the configurations, you just have to make sure these values match between what you're configuring on the device and what's configured in ISE. You define your SXP peer. This could be a ISE PSN, or it could be one of those SXP reflectors that I talked about earlier. And that's really the extent as far as the configuration. So what I want to do is just take a couple minutes and do a quick demo to show you how all of this actually works. Oh, and actually before I jump there, this is the topology I've got set up for this demo. We can see we've got a branch on the left with a switch which is capable of SGT inline tagging and enforcement. We've got a device attached to that switch. It's assigned to SGT10 based on the little map I've got in the corner. I then have an SD-WAN router which is going to propagate that SGT. I've got a data center where my ISE node sits. And then I've got a router spun up in AWS. It's connected to an AWS Transit Gateway, and it has two different VMs sitting behind it. And the VMs are in the same subnet on the same VPC, but one is assigned to SGT20 and one is SGT30. And so I'm going to just kind of walk through how we can build a policy and enforce it between the employee and those VMs in the cloud. All right. So first thing, let me just show you, this is ISE. I've got my TrustSec policy. It's very simple for this demo. I've got something pre-set up, and then we'll make a tweak to it and show how the tweak gets pushed and actually affects it. Basically, if I look at my source, which is on the left in the different rows, I've got my source SGT of 10, which is named trusted users. And I've got a permit HTTPS only SGACL towards my SGT of 20. And I've got a deny SSH towards my SGT of 30. Now, where I'm configuring these permit HTTP and deny SSH is actually under my components. So these are my security group ACLs. You can create as many of these as you need, and you can apply them to the different cells in that matrix. If I look at an example here, this one is my permit HTTP only. It's going to permit anything with a destination port of 80 and deny everything else. So this is a very simple SGACL, just to kind of demonstrate how this works. The other piece to this is we've got my two virtual machines in AWS, and those virtual machines don't have a way to authenticate to the network. All right, we just kind of have to trust them. But we can do static bindings, right? So here's how I'm actually mapping my AWS VMs to this specific security group tag. So we can see that my VM that ends in 20 is going to get assigned to the SGT of 20, and then the one that ends in the IP of 30 is going to go into the 30 SGT. And that gets pushed through SXP to my two SD-WAN routers that I have running at AWS. So that's how those IP to SGT mappings get distributed. So let's take a look in vManage. I'm just going to show you a couple things. So if I go to the devices, and I look at one of my AWS routers, I go down to real time, and there's some useful commands I've got in the PDF that I just don't have time to talk about in the slides. But you can also issue those commands directly from this real-time menu in the GUI. So if I look at my SGT map, I can see I've got these two IP to SGT bindings. And over here on the right, you can see those are coming from SXP. I can also look at my SGACLs. So that's the permissions. And we can see from source SGT 10 to destination 20, we've got permit HTTP only. From 10 to 30, deny SSH. There's a default one on the top. It's really not used, but it's there anyway. All right, so I'm going to do a quick test. We're going to create what we call a network-wide path insights trace. This is a really cool tool in SD-WAN if you haven't seen it before. What it is going to do is actually go out to the site that I'm going to specify here. Let me just do Cisco Live 24. I'm going to pick a site. We'll just pick my branch. I'll pick a VPN. Let's do VPN 1. And it's going to capture information about all of the flows coming in and out of that branch. And we can actually see how the router is processing them. So we'll be able to see the SGT get propagated, and then we'll be able to see the enforcement on the remote side. So this is just a good way to actually prove that what we've configured is working. So I'm going to go ahead and start that. If you haven't seen this tool, it came out in 20.6 of vManage. This is 20.14 I'm running, which is a newer GUI, but this tool's been here for a long time. Now I've got a workstation, right? This is the user, the employee user that gets an SGT of 10. So we're going to check out my two servers that I've got. So this is my SGT of 20. And you don't need to applaud. I built that web server myself. Pretty fancy, right? I know, it's impressive. If I go to 30, watch this magic. It's going to be blue. So we're able to get from the host to both the web servers just fine. And if I go back to that trace, let's just look at what's actually happening. So if I click View Insights, and I go down, and I should have put maybe a filter in place, because naturally Microsoft's trying to reach out to a million different things at once. So we'll do a quick search. Or actually, maybe I'll do completed flows. Yeah, so here's one. So this is going from my workstation to the .20. Up here in this flow table, it's showing you the upstream and downstream directions, but what I really want to do is go down to the advanced views. And here's where I can see the ingress, right? And I can click on this, I can see it came into port Gigabit Ethernet 2. If I look at the SD-WAN forwarding, the piece of magic I'm looking for is my MData type. So I can see that that packet is coming in and getting mapped with an SGT of 10. We're then transmitting that packet out Gigabit Ethernet 1, right? It's going to be across a specific tunnel. You can see the tunnel source and destination. On ingress, right, so on the remote side, and this is actually going across the public internet, 'cause that's actually in AWS, and the other router's sitting in Cisco. We can see that we're receiving again that SGT value of 10. So this is that propagation piece. On the we can then see we're transmitting that out the LAN interface, and it's being permitted. Now let's go ahead and do a change to our policy. So let me go back to my TrustSec policy. And this is the power of SGTs. I can go into this matrix. Let's just blow away this SGACL. And then let's do a final catch-all of just deny everything. So we don't want anything going from source of employee to SGT of 30. Let's deploy that. So if we look at this, we can see completed sending 3 TrustSec COA notifications to 3 network devices. So this is actually saying we've went out and alerted the routers in this case of that change you just made. So again, if I go back into SD-WAN Manager and I go look at that AWS router, we should see a different permissions map now that we've made that change. So if I go CTS, my permissions, yeah, we now have a 10 to 30 deny IP. So it updated, that quick. If I now go back to my workstation, let's just make sure we can still get to 20. Because, it's a demo, and you guys would love to see me scramble. Now, if I go to 30, it's probably cached. Let me just refresh it. You can see it's spinning. So this is going to time out eventually. If we then look at, for example, my counters, so if I were to look at my role-based counters, we can see I've now got 17 deny packets. Right? If I were to refresh that, we would see it go higher. So it's actually denying traffic, yeah, so now it's up to 19, based on that new policy that we created on the AWS router before it's hitting my VPC, which hosts my virtual machines. If I look in that network-wide path insights view, we should see some packets now, or some flows, that are showing drops. So let me go back to my view insight. And this is a good way to troubleshoot, right? My user calls and says, hey, I can't get to my .30 server. Why not? You can run a trace like this, say, go try again, and let's see what's happening. Let me refresh this, just get a newer. That one was like halfway completed from before I pushed the policy. It should have more completed flows now. Oh, can't type. Here we go, got a bunch of them. Let's hit refresh. First hint is you can see it's a remote drop percentage of 100. meaning we're sending the traffic across the WAN, it's getting dropped on the remote side 100%. If we go back down, we can look at our SD-WAN forwarding. Again, the packet's coming in with an SGT of 10, right? We know that. We know it's getting propagated across the WAN, so it's still there as 10. The piece that's new here is we have this SG output SGACL. And so we can now look at the source and destination SGT because it looked up that IP to SGT binding. It then looked at the access list that's applied for that specific 10 to 30, and it dropped that packet. So that, in a nutshell, is how SD-WAN propagates as well as enforces on these SGT tags. All right. I know the highlight of that demo was the web pages, but let's go ahead and a couple other things. All right. So one last feature that you could make an argument it's segmentation based or not, but it is definitely highlighting the capabilities of ISE and SD-WAN integrated together, is this identity-based firewalling. And so Cisco SD-WAN has a whole set of security capabilities built into the solution. Everything from firewall, which can use things like L7, applications, FQDNs, geo-signatures, all sorts of stuff, IPS, AMP, and so on. I'm not going to read the slide. But one of the things we've built is the ability to, within that firewall, make rules based on user and group information that we're able to pull from ISE. So as ISE is authenticating users through probably an external identity store like Active Directory, we're able to then take that information that's getting mapped and created in ISE and push it into SD-WAN so that you can create policy based on source and destination roles or actual individual users. You can also build policy in SD-WAN based on SGTs. Usually there's not as big a use case because you want to use the ISE policy to enforce SGTs, but it's there if there's some interesting use case that you need it. The way this integration works is we've got our SD-WAN controllers, right? We've got manager, which is the GUI, and then we've got the controllers, which act as the control plane, and then we've got ISE, and we've got our users. So a device, well, first of all, you integrate the manager, the SD-WAN manager to ISE, and it's going to pull down all of the users and user groups that are in ISE, as well as the SGTs. Once you have those in ISE, you're able to build policy, or I'm sorry, in SD-WAN manager, you can build firewall policies that then reference those users and groups in the source and destination of the firewall rules. So once you've created that policy, the policy gets pushed to the edge device. And so you're creating it centrally and then pushing it out to your edge routers. The controllers are also going to Cisco ISE, and they're getting the user to group to IP bindings. Right, because the router itself doesn't have any knowledge of what a user is or a group. It knows what IPs are. And fortunately for us, ISE knows as well which IPs are tied to which users and groups. We then propagate that information to the edge router using OMP. So the same protocol we use to send our routes to the router, we'll use to send those group to IP bindings. And then those get inserted into the data path. So based on whatever policy you've created, you can permit and deny traffic using those specific rules. And again, we then would log and report all of this. Same thing we've done with all of the other firewall capabilities in SD-WAN. That's basically what this feature is. Didn't have time to do a demo, but certainly if there's more interest around it, feel free to reach out. We can have further discussions there. So let me go ahead and wrap up. And we've got a few minutes to go, and I'll take some questions as well if there are any. The thing I wanted to talk about last as far as closing, really the goal of this was to just show some tools that are available to help achieve segmentation. Right, as companies and threats become more and more sophisticated, we're going to need to have a way to segment our networks. SD-WAN and ISE, those are just some tools to help achieve that. And you have different options depending on the use case. Not every customer is going to go full-blown micro-segmentation. Maybe you can do something with macro-segmentation that helps solve some of the problems you have today. Any questions before I kind of wrap up? And if not, that's okay. We can give you a few minutes back. Certainly ask them in the room. I'll take a look at that as well. Please, this was a new session, so let us know what you thought, if it was worthwhile or not. Happy to review those and would very much appreciate it. That said, if you have other questions or you think of something throughout the day, stop by. There's a booth in the World of Solutions, or feel free to add something into the room, and we'll answer it there. Thank you.